Oxidizing Ocaml, Rust style ownership in Ocaml, which is, I mean, this is, for anyone that doesn't know, Ocaml and Rust share a lot of similarities.
They
Ocaml is a
do.
lot more functional, but has concessions for Rust or for imperative style programming, whereas Rust
Yep.
is probably, I'd argue, is more imperative with a lot of
Yep.
concessions for functional programming. So you kind of get,
That
I,
feels fair.
I feel like Rust is probably a little bit nicer just to look at if you're not used to the functional style, whereas you can go
Yep.
pretty imperative for Ocaml, and that's fine. And so Ocaml is also garbage collected, meaning that
True.
you don't have to think about all the crap you do with Rust. You want just something that floats around for a while.
Yep.
Bam, everyone has a reference. Day's over. It's
Right.
fantastic.
No problem. You
No
want a
problems.
pattern match and return the thing from the pattern match? You don't have to write dot clone dot to stir dot and stir dot and then put the lifetime. You just like return the string from the first string thing.
Yeah,
You know, you just like move them out of there. No
it's true.
problemo.
Writing performance Rust is truly a difficult feat because you really have to be able to stop cloning things.
Yeah.
It's just, you know.
But then like you hate not cloning a lot of the times. You're like, holy cow, I just need to add a lifetime in 95 different places now.
All right, this one property is slowing down our system. Let's add a single lifetime. Oh wait, it's actually 95.
That's gonna be 4 weeks. It's like the let just add a button, you know, like the for Rust, the just add a button is just add a lifetime.
Just add a
Like,
lifetime.
no!
All right, anyways, okay. So Ocaml, if you don't know, Jane Street has largely been the champion of developing Ocaml into a modern era. Is that fair to say?
They do yeah, I mean there's some other people doing really interesting stuff, but Jane Street has been pushing, I would say, a lot as well in sort of like the exploratory aspects of the language. So they have like unboxed types and now the sort of like oxidizing OCaml and some other stuff like that, which I think will but we'll read in this article. I think
Yeah.
it like these ideas are gonna super click with you
Yeah.
after writing Rust, but then the thing you have to remember in the article is it's only showing you the places where you have to care about doing this. Most of the time, you just don't do this and you just write normal, regular code with garbage collection and you like can actually ship your product.
I like that. All right,
Yeah.
Ocaml isn't a pure language. In fact, well, I mean, pure functional. Do they mean that? In fact,
No,
records
pure
contain-
in terms of like you have to account for side effects and things like
Oh,
that,
okay,
right? Or
so-
like there exists mutability.
Okay, so in other words, unlike
Mm-hmm.
Haskell, your final product isn't a white paper.
Right, exactly. Like it runs and maybe like someone makes money off of it. I know that that's kind of frowned upon in the Haskell community.
Yeah, it is. It truly is.
Yeah.
It might even be frowned upon in the Rust community as well. I can't tell yet. In fact, records containing mutable fields are relatively common. The compiler also doesn't track the values may be referenced, so must assume all values are potentially shared. At runtime, this means several parts of the program may hold pointers to any particular piece of data. As much as this, like, that pattern sucks, which can be kind of a headache, which is what Rust tries to solve, it also is just extremely practical. It just,
Yes.
you know, that's why Go just tends to be really easy for someone to jump into. All right,
So
shared
one thing that's cool though is like you do have to mark the field mutable in OCaml. So
Yeah.
like fields are immutable by default.
I
which
do
is
like
cool.
that. I do like that.
Yes.
That they do what I think is the most important thing in any language, which is read only is default. Mutability
Yep.
is the thing you specify. So you're like pre-planning for something to change, and anyone can see that the type is a type that may change, which is nice.
Exactly.
All right, shared mutable data is notoriously difficult to reason about, and doubly so with addition of concurrency. Conversely, pure functions provide useful guarantees, so Ocaml encourages a side effect-free style. For example, records support functional updates with preserved immutability. Okay, so we have type A. This means the tick A is not a lifetime in this case. A tick A is
Correct.
the we don't know what type it is. Correct.
Right. It's basically like a type hole. Like you could
Yeah.
put whatever type you want into this spot.
Yeah. Yeah.
Yeah.
They use the term type hole. Generic might be another way people might be pretty used to hearing
Yes.
it as. Okay.
Yes.
Let clear box with X equals none. Value clear
So-
box is just like it just changes the box, right?
Yep. Yep. And then like if it had other fields, in this case it doesn't really have any other fields, so it's not as exciting. But it would like copy all the other fields into this new one. So it doesn't like update the previous one, right? This is like creating a new copy.
Okay.
but you don't have to write all of the fields. And so it's kind of like dot 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 style thing
In JavaScript.
JavaScript land, except I think not as expensive.
Yeah,
I
you'd go
think
dot
so.
dot dot original object, and then you'd go
Yeah.
the field you want to overwrite undefined. That'd be the equivalent.
Right.
All right.
Yeah,
Unfortunately, immutability comes at a cost. A functional update allocates a new record. Since other code may hold references to the original code, we will illustrate the result here. Purple blocks are live values, which become red when unreferenced. Before, we have a record and some. Afterwards, we have a record to none. We do have a record that goes to X, which is that same sum value, because we've now kind of cleared out that previous value. We're no longer referencing it, but we still have them living in the GC, right?
Right. So we had to allocate a new record to put none inside.
Okay.
Yep.
Writing to an explicitly mutable field would not incur this allocation, but instead exposes us to shared mutability. Ultimately, immutable updates only approach this problem from one direction. We could instead imagine eliminating the shared portions of shared mutability. If we knew that our code holds the only reference to the original record, the functional update immediately makes the original value unreferenced, available for collection and reuse. Therefore, the runtime could equivalently perform an in-place update, even though the type exposes an immutable interface. Oh, I see what they're saying.
Mm-hmm.
Okay, because this record is solely, it effectively have a ref count of 1. The
Right.
only thing you need to allocate anew is a new option type right here, right?
Right. Yep.
That's pretty
Which is
clever.
really cool, right? Because it's like, well, if the compiler knows that there aren't any other references, right, and it can't get referenced again, well, it can just do something way smarter, like not allocate.
That's actually super clever. That's
Yeah.
super clever. I like that.
Mm-hmm.
One of Rust's primary design goals is to entirely forbid shared mutability. It does, which is achieves by only allowing mutable values to be referenced uniquely. In Ocaml, uniqueness isn't a strict necessity, since the garbage collector can handle cyclic lifetimes arising from unrestricted mutability. However, we still stand to benefit from optimizations and expressivity enabled by unique references. In fact, in part 3 of this series, we'll see how uniqueness enables us to statically prohibit data races in multi-core Ocaml. Oh, that's pretty cool, getting even the safety level of Rust without Rust. That's pretty cool.
Right. Yeah, especially for, like they're saying, for once, this whole article series is leading up to this idea, about how do we write multi-core code safely, right? Because anything can happen.
Yeah.
Right. So, and how do we still do that performantly without copying stuff every single time we want to do anything, blah, blah, blah. Right. So we're kind of building up the language tools that you need to be able to solve this problem, along with a whole host of other problems. So that's kind of what's going on.
Rust Fearless Concurrency is just an arc mutex.
Yeah, right. But and as we've said many times before, the reason I don't have to fear concurrency in Rust is because I've never been able to run it in production.
I part of me refuses to use Rust with HTMX because I don't want HTMX to be looked at as a white paper language. I gotta avoid that. All right, the uniqueness mode. A variable has the unique mode when it is the only reference to a particular value in the entire program. Variables without restrictions have the default shared mode. Okay, so standard programming gets shared mode, but apparently there's now a new mode you can toss on unique. Previously,
well, remember, modes are not, they're not for the program. They're for particular values, basically, right? So they're kind of like a type, but they're not the types, right? So
they're
types,
not a type in the sense that if you make an update to a struct, you don't have to go through everywhere to make updates, I assume.
Right, yes. And then the other thing is the type inference of Ocaml still works just the same, right? If this thing can take an int, it still only can take ints. It doesn't matter necessarily. So those are orthogonal problems. So they're going to go through it. But yeah, so they're saying we have this new mode about uniqueness, right? Is this thing unique or not unique?
Yeah. And for those that don't quite understand it, you just kind of got to imagine promises and how they color your function blue. In Rust, when you do, say, lifetimes, it actually colors your struct in a sense. You cannot define your struct without defining the lifetimes, much like if you have a promise, you have to kind of alter how you call that function. And so there's this whole... Yeah. It's a very similar thing. Rust has colored structs, whereas this is avoiding the colored struct problem but getting all the usability of it all, right? Is that
Yeah, and
effectively what's happening here?
Yeah, and I think the other thing is it's kind of like the main difference I would say more is that it's focused on like it's opt-in, right? Like you only opt into these ideas for certain parts of your program where either it gives you like some additional type safety in the sense that you want to make sure no one else can like hold this pointer to a file, right? Like
Okay.
it's actually nice to be able to say,
Yeah,
no,
restrict
you
those
can't
things.
like leak this file pointer. That's a no-no. You know, like it needs to be safe for this to do, right? Or that you want to do something like the example at the beginning about, oh, I don't want to do extra allocations.
Yeah.
Right. So, like in those two cases, you would be like, yeah, I actually do want to opt into those for these cases, but the rest of the time I don't need to worry about it. Right. Which is different from us because you always have to do it if there's a reference. Right.
Yeah, I like that. I like the idea of opt-in safety or opt-in uniqueness, as they're calling it right here, which is actually it's pretty clever, right? If you don't want to you want to guarantee you cannot leak the file handle, such that a
Right.
file will stay open longer than you realize. Well, you just mark it as unique. It can no longer do it, and then you have safety in the one thing that needs safety. Whereas, does your int really matter? Does your, you know, like, do these things really
Does the
matter?
string?
Yeah.
It's like, okay, it's just so they're going to do some examples, but like that's one of the things I miss in other languages a lot from Rust is that ability to like drop something by like the function signature, right? You're saying like, no one gets to touch us anymore. We've closed the file. I think that might even be one of the examples in this
All right.
article.
Well, let's
Sorry,
start.
pre-read.
Yeah, let's go. Yeah, pre-read. You've definitely pre-read. I haven't yet. Previously, we saw the compiler tracks the variables, which variables may escape their region. These were global. Uniqueness can be handled in a similar fashion. Tracking which variables may have aliases tells us which are shared. Unique variables are hence those used at most once. For example, given a function that takes a unique argument. Okay, so this one takes only unique arguments. It doesn't have the type, right? But it's a unique. It's a singular reference one. We are no longer allowed to use this function in a way that violates uniqueness. So we can't go foo, consume x, return x.
Right,
X is unique, is used uniquely, so it cannot be used twice. Oh, very cool. Okay, I see what happens here. Effectively, it is just like Rust, where you just call a function without a reference. You've effectively created non-reference calling. You've moved X. Oh.
Yeah. So that's like, right. You're
That's
like,
the file handle case.
you've written some Rust and you're like, oh, I totally get this. Consume does what it says in this case, right? Where it can take any variable that is unique. And then it just says, you can't use it anymore afterwards. I'm not going to return it back to you or anything. It's gone. It's been moved.
I like that. Ocaml's uniqueness mode mirrors a similar concept in Rust, where values are unique by default. When passed to a function by value, a Rust variable is moved. Ownership is transferred to the callee, which has free reign to mutate or destroy the value. Submoding. Or submoding. A unique variable may be safely used as if it were shared. So unique is a submode of shared. This hierarchy is reversed compared to locality. The non-default mode, unique, is the submode. In this sense, that might be, you might have to read the previous article to understand what they're saying, but I don't think you need the knowledge of the previous article to really
they'll give you an example of how it works.
Yep. In this sense, unique behaves like global and shared behaves like local. For example, we can construct a shared variable by referencing a unique value, but not vice versa. Okay? So let bar unique x, then we return out two references to x. Is that what's happening here?
Yeah, so like they are kind of like references, but they're really, you should just think about them as like shared. So instead of being unique, they're shared now. So notice how like on the right side of the arrow in the tuple, there's no uniqueness constraint on those two like tick A's, the alphas, right? So it's basically saying like outside of bar, you have to pass me something that's unique. And then bar can do whatever the heck it wants with it. We don't care, right? And so then it's like, it's just going to return two new things. And you don't know that that's the same from the type signature, right? And from like the modes, but that's fine. Yep.
And so does that make X no longer unique once it goes through this function? X is now shared.
Right. Yeah. Just like how you could, this is basically like cloning, right? Like you could take in an X in Rust and you could return x.clone, x.clone or something like that, right? That's effectively what we're doing because we get to fall back to a garbage collector. Right. Like it doesn't matter.
Cool.
You don't have to write X clone. you just write X because the garbage collector will still handle that in this case.
Okay. Uniqueness submoding relation makes it more intuitive to interpret a unique function parameter as promised by the caller. A unique parameter means the caller promises to provide uniquely referenced values. The callee is hence allowed to overwrite the value. A shared parameter does not encode a promise from the caller. The callee must assume the parameter is aliased. Nice. Okay, I like that. So using the following syntax, we can perform an in-place update on a unique record. All right, we can do a unique box, overwrite box with X, boom. So now we get the same value back out, and we're returning back out the unique reference to it. Okay, cool. So unique works on both sides of this, on the right hand and the left hand, or as return values. Okay, cool. So you can do unique operations that you have to return.
Yep.
Okay, just like Rust. Okay. It may alarm you to notice that clear returns a box. Does this let us cast the box to a new type in place? The answer is yes. It's perfectly safe to do so. Oh, yeah, I didn't even notice that. Tick A, tick B. So depending on how you use it, you could actually get a new type coming in here.
Yep.
Ah, that's pretty clever. No other code maintains a reference to the box. It can be referred to as a value of that stale type. Oh, I actually really like this idea. The result demonstrates the unique variables provide another important capability, updating the value's type in place. Such an operation is known as strong update and lets us write, for example, an in-place map function. Okay, so we have a function that takes A is unique and returns B is unique.
Yep.
And then what's this thing right here? And this is... how
and it
do
has
I
some
read this?
box,
I suck at these things. Okay, this is the name. This is argument 1. This is argument 2, right? I'm still pretty weak at the old Ocaml. Okay, so match box with X. If it's none, it remains none. If it's some, it now translates it into f of X, which casts it into something else.
It calls like the function f that you're passing on like the value that's inside. So this is like option.map, basically, right? Except that it's saying like you don't need to allocate any new like options, right? You're going to overwrite the option inside of there, and right, like if you were chaining this through or something, right, like you could imagine that you're going to call like option to map on something and then option on map again and option on map again, right, or whatever, right? Then what's cool, right, is like the types can be changing along the way, but you're not allocating like garbage for every single spot. You're going to overwrite it.
Yeah, because for those that aren't familiar with JavaScript, if you do .map on an array, it creates a new array of equal size.
Right.
And so that is, whereas this won't create a new array. Instead, it will mutate the given thing, it sounds like, or mutate the given items within it to be of new type. And I assume you have to do some fancy-pantsy on the outside to be able to do it with an array. But this is just with a singular type. But still very
so
cool.
That's like giving you the idea of like, oh, this lets you keep type safety, but also like not generate a bunch of extra stuff, which is very interesting.
Borrowing. Unique variables also empower users to write safer API contracts. Procedural resource management is one obvious use case. So let's attempt to define a simple set of functions to manipulate files. Okay, type file. We have open, read, close. All right, since close requires a unique parameter, we can be sure that files are never used after being closed. Oh, that's pretty cool.
Yeah.
Okay, I like that. Okay, so we have print and close. It takes in a unique file, print line or print end line, read file, then just close the file. Close file. Let's see, file is used uniquely, so it cannot be used twice.
Yep. So they're going to introduce a new concept to solve this problem.
Okay, yeah, because I was about to say, how do you do a read file and a close file here?
Yep.
I would assume that you'd have to have it, like, to solve it without any new constructs. You'd have to have this thing to be unique, and then you'd have to return out the string plus a reference to the file that's unique, right? That would be
right. So yeah, you would have like a read, and that would return like a tuple with a unique file and a string or something like that, right? You could do that similar idea. Yep.
All right, even though read does not require a unique parameter, we are no longer allowing to close the file. Using a unique value at the shared mode is a one-way transformation. Okay, perfect. Once we create a single shared reference to file, we're no longer allowed to use the file uniquely. This makes perfect sense. This behavior seems overly restrictive.
And just like before we go, like notice how that just kind of like happens, at least in my mind. I haven't gotten a chance to like play with this a ton. It basically happens like automatically.
It
right?
happens
Like it's just like
transparently. Yeah, you don't have to think about
you just
things.
like he just like used it twice. And it's like, dude, you can't use it. It's unique like that. So either you like remove the uniqueness constraint or you figure out what you need, but you don't need to go like crazy to do a bunch of extra things for it, right? It's like kind of happening automatic, which is really cool. It's like,
it is nice.
Feels
I like
very,
this.
yeah.
It's a very simplified version of the borrow checker / how values work in Rust without all of the other parts. This behavior seems overly restricted, right? We know that read itself does not use the file uniquely, so if it also doesn't leak any references to file, we could keep using file uniquely after read returns. Fortunately, we've already discussed a mode that expresses this constraint locality. Read file local, okay? Print close, read with an ampersand. So what's going on there is, do you have to do a different type of syntax? Okay, the syntax reference to file denotes borrowing, which weakens the mode of file to local shared. Oh, interesting. The resulting reference cannot be leaked by read. So after read returns, we still only have one reference to file. Because you're saying, hey, this is a local share, and it's only locally shared within the read, and the read uniquely, can't do that. It only accepts a local variable.
Yep. So that's what we did from like last article, right? Was local was saying like you can use this inside of yourself, but you can't leak it out to the global scope, right?
Yeah.
So this is once again, as we're going to say, like the Rust borrowing is less restrictive as the callee is parameterized over the true lifetime of the borrowed value. That's that last sentence before we get to exclusivity, which is basically just saying like,
I thought you said
in Rust,
that free-handedly, and I was like, TJ, you sound extremely smart when you talk like that.
Yeah, no big deal.
You sound like an academic blog article when you speak like that.
I sound like I write Haskell in my free time, But like, so what they're saying though, right, is in Rust, you can make unlimited numbers of lifetimes.
Yeah.
Right. But in Ocaml, they're saying like, okay. But like, maybe what if it's pretty much just like it's used by this function or it's not just used by this function?
Yeah.
Which is, if you think about it and you think about all the times you've been writing Rust, like the vast majority of the time you're doing that, you basically just want to say like, I'm referencing it or I'm owning it. Like that's kind of, what you want to do for a lot of situations. And so in this case, they're basically saying like, instead of having to specify a bunch of different lifetimes, you're going to say, when I use ampersand file like this, I move it from a unique to a local shared that has some guarantees. When that function's done, I know no one else can be holding a reference to file. So it's still unique.
Yep.
That's how we get to use it for close.
All right, exclusivity. Let's expand our API to include a write function. A file represents access to mutable state, and we're avoiding shared mutability. So write should require a unique file. Okay, that seems fair to me. It takes in a file plus a string to write and returns nothing out. But when we try to use this function, write file data, closed can't be used twice because it's unique. Okay, fair. If we pass file uniquely, it cannot be used again. While we could return file from write, that's what I was suggesting originally. Piping...
Big brain?
Yep. Yeah. Medium brain. We'll call it semi-smooth brain.
Like piping, 3 wrinkles at least.
Yeah. It solves the problem, but in a non-desirable way. That's actually how I program.
It solves the problem, like autoplay.
Not desirably, but he solves them. All right. See, while we could return file from write, piping unique values through every function call isn't a good solution. Ideally, we want to express that although our function mutates file, it does not consume it. To better handle this case, we've added a third mode to the uniqueness axis, exclusive. Which sits between the initial options. A variable at the exclusive mode is the only active reference to a particular value. Interesting. Specifically, exclusivity expresses that while the other references to this value may exist, none are accessible until the conclusion of the exclusive references region. Therefore, we may freely mutate the exclusive value, but we may not use it uniquely. Okay, bam. So this one is local exclusive. Oh,
yep.
Interesting. Okay. And so we can use it, we can mutate it, and then we can close it. Bada bing, bada boom.
Right.
Okay.
So once again, right, we think about like what local is. Local says you can't escape the function. And exclusive is saying I'm the only one with this reference. So it's like kind of like mute, mute reference in Rust. Because when you have a mute reference, you're saying I'm the only one that can have this mute reference, right?
Yep.
But it's a little bit, like that's basically what exclusive is, right? Because you think about like the way you have in Rust, you have the owned value and you have a reference, and you can have like only one person has the owned value. As many people as you want can have the reference, but only one person can have a mutable reference at a time. That's like basically the same idea here. Does that make sense?
It makes sense.
Yeah.
Yeah, I like all the things we're saying. Because the call to write borrows file. By the way, we're becoming dangerously close to an educational channel right now. I want
that's
you to
okay.
know that. This is.
We joked enough at the beginning, so I think it's safe. We tricked all the people who are looking for education. We got them out.
Yeah,
you know?
okay. I'm very worried about it. Because the call to write borrows file exactly once, file has a mode local exclusive. If the file was borrowed multiple times, its mode would instead be weakened to local shared. So we can do this. Okay, so write takes a local exclusive, and it takes a local exclusive file again and produces a string to the unit. So we do it twice.
Yeah, this is just an example to show like you can't borrow this twice. Basically.
Yeah, you have two. It's allowing two references. You can write two files at the same time, effectively. But it's saying found a shared value where an exclusive value was expected. Yes, because it's now being used twice. Okay.
Yep.
I wonder how much this is going to slow down the compiler. I guess not too much because it doesn't have to do it for every variable for all time. It only has to do it for a very small subset. Thus, you get 99% normal compile times with the 1% slower on just this particular small piece.
Yeah, my guess is since Jane Street is like actively using this and they have like unlimited amounts of Ocaml code, they're going to make it go zoom zoom. Like I don't think they would sacrifice a bunch of like Ocaml's really fast compilation speeds just so that they can do some of these things.
Yeah, but if you think about it, let's say it's 10 times slower to compile because it has to do all this fancy footwork. It's still one variable that it does in like 3 locations versus your 10,000 variables elsewhere. So it's like, does it really matter? Well, most of the time it just is like your global shared, go, 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 go. And then all of a sudden this one, it's just like, oh, hold on. Let's be a little bit more specific right here. I love
and
that.
They are working on, my understanding is like inferring these for where like it's possible for you to know, at least for like the locality, so that you can do less allocations. So like there is like, I mean, if you can just apply less GC pressure and also use less memory and also have things just run faster with exactly the same code, that is a big win.
Yeah,
right?
you just go from heap to stack. It's literally like a magnitude. It's a magnitude win. All right. Awesome. This exclusive mode is not just useful for resource management. It also expresses that a function may mutate a record, but never strongly updates it. Give an exclusive variable. We know our code has the only active reference value to the value, but later code may inspect it at the current type. Therefore, we also introduced exclusive mutable fields. Okay, so this is mutable only when it's exclusively held.
Yes.
An exclusive mutable field behaves. Oh, that's also really good because it guarantees that way you can have mutability and guaranteed singular reference, right? Effectively, or singular update,
and like,
which allows
for everybody
for fearless
else
concurrency.
Yeah, fearless. It's gonna look like it's going to look like it's immutable all the other time, which is nice. Like, you know, you're basically saying like most of the time this is immutable, right? And then occasionally we're going to have something that like actually owns this thing is able to change it. Like, cool, that makes sense.
Yeah.
Yep.
Safe mutability. An exclusive mutable field behaves as you might expect. It may be written to via an exclusive reference, but appears immutable when accessed via a shared reference. Beautiful. With exclusively immutable fields, we can enjoy the performance benefits of mutability without the strict move semantics of uniqueness. Okay, so we have a local exclusive counter. Bam, bam, bam. Look at how that looks just like beautiful, right? Making individual fields as exclusive mutable is a natural extension of Ocaml's current mutability story, but notably diverges from Rust's approach. In Rust, variable bindings are marked as mutable upon declaration. That is, mutability becomes another deep property, perhaps a mode. Despite this difference, Ocaml's uniqueness mode access now mirrors Rust's hierarchy of references. I don't quite understand. I think I understand what it's trying to say, but let's see what it says.
So like, well, just to be clear, like in Rust, you say like let mute x equals this thing, right?
Yep.
Like in Ocaml, you say like this type, this field has mutability or not.
Okay.
Right. So like that's different in terms of like when you mark mutability.
Okay. A unique variable is akin to a value in Rust. Passing a parameter by value allows the callee to destroy it. Yes, this makes sense, which means ultimately you can get very close to being able to infer, I assume, stack operations at this point. Is kind of where this is all going to.
Many things that can go zoom zoom after they figure these out. Yep.
An exclusive variable is akin to a mutable reference in Rust. Passing a parameter by a mutable reference allows the callee to overwrite but not destroy the value. Yeah. A shared variable is akin to an immutable reference in Rust. Passing a parameter by immutable reference restricts the callee to reading or copying the value. Perfect. There is one important difference. Ocaml's references are not parameterized over lifetime variables. Like we saw in part 1, this means uniqueness does not lead to higher order polymorphism and doesn't interfere with type inference. All of that to say, you don't have to go everywhere and just denote lifetimes crazily. Is that
exactly?
Is that
yep.
fancy speak for I don't need to update 90 places to make this individual thing local?
Yep. That's like one side, and the other side is that like all the type inference that worked before in Ocaml like still works with the solution. You don't have to write the type parameters for like every single function and every single return, but we still like Ocaml has types. Like for people who don't know, and maybe you're not familiar, like everything is type safe.
Yeah.
Like with a real type system. So that's like the two sides of it. Yep.
All right, so far we've seen how uniqueness and locality access interact to represent ownership. Unfortunately, we can now write the following code. Oh, unfortunately. Okay. We have type, it's a box as an option A, right? We don't know the type, right? Wrap, unique box, is a function to a box. Okay. So we make a unique function that returns the box. Let unsound, unique box, get wrap box in, A equals... Hold on. Okay, so this is the function that returns box.
Yep.
A is the value from that box. B is the same value. So we went from a unique one, and now we have shared ones. Overwrite A with X equals 0. Overwrite B with some string. Okay.
Not good.
I see what happens here. You have two references, and now you're actually trying to overwrite in place effectively.
Yeah, and that's real not good when one's an integer and one's a string. That's a no-no. That's TypeScript land. You know,
yeah, we don't do TypeScript stuff here.
We don't want to do that here. We don't do that here.
I do take advantage of any quite a bit when I have to. It can be very nice. Just throwing that out there.
Yeah.
TypeScript doesn't have polymorphism. It has crazyism. You can just make it anything. Naively, applying a get simply returns the wrapped box, but that means invoking get twice creates two supposedly unique references to the same box. Violating uniqueness breaks type safety, as we can use strong updates to refer to the same value at multiple types. Okay. So therefore we must not allow wrap to return a closure with the signature unit to tick a box unique. We know the resulting function may be executed once, but it is unsafe to invoke it a second time. More generally, any closure capturing a unique value must be ran at most once. Okay, so this is probably where fn once comes from in Rust.
Look at this guy. Pre-watched. Put it in the chat right now. Pre-watched.
Did I get it? Tell me I got fn once.
You got it. Go. You got it. Nice. Yeah, you did.
All right, to encode this restriction, we pre-watch. Let's go. We will define a third mode access, linearity. There we go. I got it. I got it, chat. Calm down. Sit down.
Confirmed he didn't pre-watch, chat.
No, it turns out he's too stupid to actually pre-watch this. In practice, linearity modes will almost exclusively apply to a variable of a function type, closures, but this is not a requirement. Variable with modes once carries a restriction of being used at most once. This allows to close over a unique and once variables. A variable with default mode many does not have the restrictions. It may be used freely and may close over shared/many variables. A many variable can be used if it were once, so many is a submode of once. Like locality, the salient mode once. Okay, I honestly don't know what salient means.
It's like the thing in your mouth,
noticeable
right?
or important. Okay, the most notable or important mode once is the super mode. The parameter perspective once represents a promise by the callee. Okay, so this is a lot of words, and I think it's very hard to see. I've always been very bad at understanding abstraction first and then, or principle to action. I'm much better at understanding action to the principle.
Yeah, they should have showed this code first and then did the long explanation, because you'll see the error and be like, oh, this makes sense. Yeah. It says you can only use it once.
That's why I can right away say, oh, we need a once. Yeah. I can say it right here by just a look at it, and then they explain it once, and I'm like, I don't know what this says. I know what you're trying to do, but I don't know what you're trying to say. All right.
Right.
Let Baz once XX. Okay, you can't do this. Hey, that's kind of cool.
Yeah.
I'm not sure how I feel about it, but it's neat. I'll say that.
Right. So it's just in general, you won't use this very often for like function things, and you probably won't have to do it for functions either because it's going to be inferred, just like
Yeah.
a bunch of these other things, right? But it's just saying you can only use this value once. It's actually pretty dope to be able to say you can only use a value once. But
yeah, you would. I could think of very few places you would ever want to do this, and so maybe
Except
it
for
makes sense
functions.
once you start doing it. You can go, oh, okay, this makes sense.
Yep.
In some sense, linearity is the dual to the uniqueness access. Both analysis are connected with aliasing. A once variable prohibits the creation of new references to its value, whereas unique variable states that no such reference exists. Okay, interesting. Consuming variables. Returning to our unsound example, wrap now returns a closure at mode once. When we try to invoke the result twice, the compiler raises an error. Right? Okay, once, so you found a once value that was where a many value was expected. Cool. That's actually super cool. So it truly does prevent this silly situation.
Yep.
I'm curious how this all goes in practice because it seems nice, like talking about all this, but I wonder what levels of complication does this introduce at the performance layer? Obviously, just Ocaml, you'd never have to think about this, blah, 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 but when you want to do the performance layer, is this going to be harder or easier than Rust? It appears to be easier.
Oh, I see. Yeah.
But like when it comes to it, is it going to be harder to practically use?
So from talking to some people about it, my general perspective on this is that you probably you'll still be able to write faster code in Rust, right? Like I think that's
there's a
possible.
GC involved. Rust should forever be faster.
Yep. But the thing that this gives you is that when you find those hot paths in your code, right? Then you don't have to write a whole new stack to solve the problem.
Yes.
Right. Or even you don't even have to do FFI, right? Okay, so you're writing Python and then you need something to go faster. Well, I'm going to write C now. Well, that kind of sucks, right? I was just writing Python and we
chose
have all
Python
this tooling
for convenience and now I'm somehow writing C.
What
happened with my life?
Oh, I think we need to do the Gru meme where he's pointing at the plan, all 4 spots, and it's pick Python for convenience, use C, and then
Python
writing
becomes slow
C
in this
for
one
convenience.
Spot.
Yeah,
writing C to make it faster. Writing C for convenience. That's a good tweet.
Yeah, that is. I'm gonna send that once we're done.
Okay, deal.
But that's the difference, right? Is that now you don't have to go to that other language to get the solve. You get to solve it still in the language you were writing everything else in.
Yeah.
Which is great.
And I make the same argument with Go.
Yeah,
oh, sorry to interrupt. I make the same argument with Go, which is Rust is the 100% performance case, just like C is the 100% performance case, Zig is, C++. But Go is like the 98 performance case, right? It's it's almost there. Is 98% performance good? JavaScript's the 65% performance case. You're really choosing convenience over performance.
And it's easy to make it the 15% performance.
It's very easy to make it the 15.
Yes.
It's actually you could make 10x faster code in other languages. So or even more than that. But it's kind of interesting to see all this because you're okay, you can make it faster. It seems like Ocaml has the chance to be even faster than Go. You can make it the 99.5 case where it's there's very little value that you can squeeze out using Rust, C, C++, Zig at this point because it covers the most case.
Yeah. And the other thing too, right, is that a lot of these features, they have a performance win. I mean, I'm more excited about some of them for the expressivity aspects, we did for the file descriptors one. It's nice to be able to encode that and just you don't have to rely on docs to tell somebody not to make a copy of this or not to try and write to anything after you call close or it's just nice to be able to have the compiler say, hey, you said you're not going to leak this and then you did. I like that. I want the compiler to tell that to me. So there's a lot of it that I'm excited for performance stuff. That's great. but like for locality and for like borrowing and stuff, I'm like pretty excited as well about the like type level stuff that you can do, which is cool.
Yeah, that's actually a really good description, which is performance. I mean, at the end of the day, people don't choose JavaScript for performance. They choose it because they have
True.
Stockholm syndrome. And so if you want something faster, you can pretty much choose any language. Like Java, Go, Rust. I mean, there's Zig. I mean, there's so many available languages at this point. And so now
Yeah.
Ocaml is really contending to be a good one. I like this. I do want a functional arc in my life just to really say that I've done the functional thing. Is it actually
True.
practical, or is it still
Then no
too
one
much?
can call you a script kiddie anymore.
I'm still a script kiddie, though. I only know Rust, which is like a clearly script kiddie language. But real talk, like I keep going back and forth, which is a functional programming language actually practical? Or I mean, how much, and it really goes with Rust too, which is how much of this type intensity is it actually practical? Can you produce real software with it, or is it really high thought? And it may look nice. Like the final product is like a couple lines and they're so smooth and nice. But like the boilerplate hell that lives behind those few lines, you're just like, dude, it's hard.
Yeah.
So
That's what I'm exploring as well. I'm having
Yeah.
fun with it. So
okay.
that part's good so far.
So
and I'm
far-
making progress too. So
Yeah,
that's good.
you're actually building something. You might actually release a product in Ocaml.
Yeah, and it'll be for this stream, managing React content.
Haskells. The Haskellers are in shambles right now hearing about
They
this. White
are gonna be
papers are
so
being
mad.
derived as we speak about TJ potentially writing software.
Products considered harmful. Like, oh my goodness.
So far, we've conspicuously omitted closures that capture exclusive references. Really, for me, it was inconspicuous because my brain hasn't even gone there. When a closure borrows a variable, it's not like, oh, yeah, I saw this one coming. It cannot use the value uniquely, so the resulting function is safe to run multiple times. That is, it needn't be once. However, borrows still come with restrictions. Borrowing always creates local references, so a closure that borrows a variable must itself be local. Okay, I think that makes sense. So we have a box that is exclusively mutable in this position that's always of the same type, so no type mutations allowed here at any point, or at least this one is a type hole, so yeah, it produces a... Okay, never mind. There's no, you don't do type holes at this point. You do it at the function level, right? All right. Wrap takes a box in, clears it out, throws a none into it, and then returns out the function clear, right?
Yep, right,
Okay.
exactly. Yep.
Clear. This value escapes its region. That makes sense. I think that makes sense because you have a closure that has this, and you have to denote something in here, right? You have to...
Right. Well, basically, it's like if you passed in an owned value into Rust and you returned a function that references it, Rust is going to yell at you, just like it's saying,
Yes.
yo,
Yeah.
you can't do that. You have to like fix this. You can't just pass callbacks around like that.
Yeah, which this makes sense. If you're going into the land of performance, I assume unique is also in the land. This is more of a performance consideration than anything else.
Yes.
This
Or
would be...
it's like, yeah, well, it's also like the file descriptor
Yeah.
one where you're going to say like, yeah, you can't.
But
do
I
that.
don't think
yes,
this one's...
right.
When you're doing this is because you're trying to do something that's fast, right?
Yes.
You're not...
Right. That's because you want to update memory in place. Right.
Yes. All right. So in Rust, closures that borrow values exhibit similar behavior. The function's lifetime cannot exceed that of the reference value. However, we know that clear can never outlive box because box is global. We must instead move box into the closure and allow clear to escape. To do so, we add an explicit global annotation. Okay. So box is unique. We own box. We can send this out, but this still has, I wonder what the type signature is, right? Which is it takes, let's see, wrap returns out, or it takes in a box and it returns out unit that returns, or a unit that takes in a unit that returns out.
So it's a function that like has unit as its parameter and it also returns a unit. So like you call clear and it just empties the box that you have.
Oh, I see. Yeah, it's, yes. Of course. I thought it was returning this, but I realized no, it's not returning it. Okay.
Yep.
Takes in nothing, gives out nothing, and this at separate. I don't know that one. Ownership is transferred to the closure, so box may not be used outside of clear. Correct. In Rust, this behavior can be requested by adding the move keyword in a closure. Okay, so this is a move effect. It's nearish a move keyword.
Right. Except like it's going to kind of move it, right? Because we don't have all these intermediate lifetimes. It's basically just moving it from local to global.
Yeah.
Right. And so it says, hey, garbage collector, you're going to handle this later for me, which is nice, right? Like,
Yeah,
it's
garbage
so
collector.
nice.
This is now a garbage collected variable.
Right, I
Go
don't
do it.
like box leak it,
Yeah.
and just let it exist forever. I just let it go until the garbage collector is ready to do it.
Yes,
So that's
it's that
cool.
intermediate state, which is the one that when you want box
Yeah.
leak, you just usually want
Yep.
collect it when I'm done using it, and I don't know how long I'm
Right.
going to be using it for. It was
Yep.
it
And
was
so this last
slightly
section
up.
is the most word salady one, just as a heads up.
Okay, so we get pretty word salady right here.
This is the last one, but like the short summary is pretty much like you can't have the function call itself. Basically, it's like reentrant, right? So it's gonna say like,
Okay.
yo, dog, like you can't just let this call itself. It's not clear who owns what when it's calling itself, basically. And
Fair.
so like most of the time you don't have to worry about this.
Yeah.
Yeah.
Fair. It was slightly misleading to say that closures capturing exclusive references can be run multiple times. This is true, but they're not reentrant. Intuitively, when a closure stores an exclusive reference, invocations must use the reference one at a time. In other words, they cannot overlap. This makes sense. So you couldn't have something that gets a reference be called multiple times, producing many references to the same thing. This limitation
Right. Or like imagine you were gonna overwrite a value and you had like a if this then that, and like one of the branches overwrites it with a string and one overwrites it with an int, and then like later you it's not clear who owns it and what the type should be, right? So
yeah,
you just say,
that makes sense.
yo, dog, you can't do that. That's separate. It's just as you have to let the whole function be done before you call it again.
This limitation is encoded by a third mode in linear access, separate. The separate mode prohibits the creation of new references to a value during its execution. Therefore, a separate closure may be invoked repeatedly, but only one invocation can be active at any one point. Okay, makes sense. All right, we have a separate function, f. Let separate run f. F must be the parameter being
It's just a
passed in.
function.
Yep. So we invoke that function, and that's that. Okay.
Yep.
So now run, we pass it in, and we invoke. And then we run with the function that runs and produces another function. Run, found a separate value where a many value is expected. Okay, yeah, so it's calling itself.
Yep.
Not allowed.
Not allowed.
Not allowed. Luckily, most higher order functions do not require reentrancy. It's actually really hard. Like I'm surprised it's a hard case to figure out how to do this in my head.
Yeah. You would it would be weird to actually have this problem.
If you're having this problem,
cases.
you're probably doing something pretty goofy right at that point.
Probably already have other problems.
We're in the emotional stage of programming. Luckily, most higher order functions do not require reentrancy. For example, list iter doesn't overlap applications of its callback, so it can take a separate parameter. Oh, nice. Okay, that makes sense. Now callers are able to provide callbacks that close over exclusive values. Perfect. Bam, bam, bam. Let's see. Unique is this guy. Iter function write x. Okay. Iter function consume x. Found a once value where a separate value was expected.
Right. So like consume was the function we made before that basically like moves the value. And so it says you can't actually move this in a list. Like I don't know what to do the next time something gets called. Right.
Yes, so that makes sense. Because then what is your list filled with? It's filled with voids in some sense.
You can't. We have big problems, so that doesn't work.
Okay, that makes sense. The separate mode has also corresponding Rust trait. In Rust, closures that capture mutable exclusive references implicitly implement the function mute trait, which makes invocation require a mutable reference. Because Ocaml does not rely on type bounds to encode linearity constraints, type inference is again unaffected, whereas Rust function traits further complicate the type system. I think I hear what they're saying. If you've ever used function traits in Rust, it's a nightmare. That's effectively...
Yeah, it's very confusing.
It's exceptionally difficult.
And it's really hard to make, to write a little function and pass it around.
Yes.
Like, that captures anything. Like, at least for me, I've had a really hard time, which is, a shame, because so much of the rest of Rust, you're feeling like, oh, I could totally,
it
write
feels
this little
functional.
function and close over this and, pass this to an iterator and do this stuff, and then it ends up not doing that. So you either just clone them all, or you have to write a big function and write a bunch of type constraints. So they're saying you can maybe still not do that, right? Like the examples we had just above, we didn't have to do any extra stuff to say. You just called consume and it just worked, or it didn't work. That's great.
Yep, I like that. Let's see, I'm 95% ready to get behind this. That's good. I mean, I think there's a lot of things I love. I love that that the file one, I think, was the biggest win there, which it just shows
Yeah.
you can make practical constraints in your application that are impossible in effectively every language but Rust, right? You can't make
Yes.
that guarantee in TypeScript. You can't make it in Go. You can't make it in anything, because what you end up having to do in those languages is when you do a close operation, you have to like close over / hide the file handle, and you manage
Right.
the file handle. And then when they call close, you have to like null it out and ensure that your program is procedurally doing the correct thing, versus this is actually saying at the compiler level, we'll do the correct thing without you writing the procedural aspect of it all.
Yeah.
It's beautiful.
Yep. Exactly.
Linear types go mainstream. Oh, Pick's talking in Haskell again. I don't know what he's trying to say, but I think I do.
Just more Haskellers. It's fine.
Okay, write a white paper, Pick. Okay, Jane Street's compilers team is currently implementing the uniqueness and linearity axes based on the design by Leo White and Stéphane Dolan. Anton Lorenzen, Summer's 2022 intern project produced. Wow, that's an intern project? Produced.
Yeah, I know. What kind
of interns? Like
do the
postdoc
coolest
interns?
stuff there. they have such cool interns. Yeah.
I don't know what kind of internship's going on here, but that's wild.
Yeah.
I guess at Netflix, Netflix, by the way, we produced a VMAF. If you don't know what VMAF is, a VMAF, right? This is a video media something fusion score, where 7 points is a J&D, a just noticeable difference, and it's about video quality, and it's all perceptive. And it took like hundreds of thousands of people judging scores, and then interns coming up with like an equation to do this. But the intern was like a PhD student doing it. VMAF
Nice.
is pretty cool. And we also have IMAF, which is like the same thing.
I honestly thought you were saying VMath, like MATH, but just saying it goofy, how you like to say other words. So when you typed it out, I was surprised.
Oh, no, this is not quick math here. This is actually multimedia something fusion. Video multimedia something fusion. I forget what is it called. So hold on, now I have to know, what is it?
Yeah, Pick brings up a good point. One of the previous summers, one of the interns like completely wrote a TCP stack in Ocaml, like the whole thing, so that they could use it in some of their other like projects. Just the whole TCP.
TCP ain't fun either. It's just really annoying. Sliding window, all that crap.
Yeah.
It's just a lot. I know it's only 20 bytes for the header, but it's a lot of work. All right. Jane Street's compiler team is currently... we already did that one. Let's just keep on going. Despite locality success, one might be skeptical that uniqueness and linearity modes will provide more than minor optimizations. After all, Ocaml already supports explicitly mutable fields that may be written without incurring allocations. However, with the release of Ocaml 5, mutable fields are now subject to data races. If multiple domains access a field and at least one performs a write, results observed by readers are unspecified. Absolutely. Though the program remains type safe, fortunately, the addition of exclusive mutable fields gives us it gives us a powerful new tool to combat this class of concurrency bugs. In part 3, we'll use modes to define a statically data race-free API in a multi-core Ocaml. Fearless concurrency. Arc Mutex. I'd like to see how it's done without Arc Mutex. Honestly, if you can do that without Arc Mutex, man, that is super cool.
Well, we'll just have to read part 3 later.
Yeah, we're gonna have to read part 3.
It's already out, so we can read it whenever.
Okay, awesome. Well, hopefully the Ocaml people liked our read through this time. Last time they were all pretty stoked, right?
Yeah, tell Ron, hello, Ron.
Hey, Ron.
If you made it this far in the video.
Hey,
thanks.
Say hi, Ron. Everybody.
Yeah, everyone in chat, say hi to Ron.
Everyone's just currently eyes
are glazed over. If you like signals and threads, say it right now. It's my favorite
1,400 people,
podcast.
and we can barely get a hi Ron out of them. There we
got
go.
him.
Thank you. Thank you, chat.
Which is apparently delayed. Yeah, Yaron Minsky. He's the one who asked for this one, Pick.
Oh, he asked for us to read this one?
Yeah, he said, hey, I liked your first one. When's part 2 and part 3 coming on? So I was like, yeah, let's go talk to Prime and make it happen.
I like that. He's clearly way too smart for me.
He's way too smart for us. I can't believe he liked our first one.
I'm almost a little disappointed in myself that I was even on there reading it. Look at that dummy go read them Ocamls.
It's like, that's nice for a Netflix engineer.
Yeah. He's gonna make it there one day. All right.
Yeah.
Hi,
all right,
Ron.
sweet.
All right. Hey.
Thanks, Ocamlers.
Bye, Ocaml.